I would like to introduce Dr. Eric Ravussin.
I have been tasked to talk about targeting beyond energy intake. And we know I've been for 50 years in this area of obesity research. And I think that we are at the golden era now with some so potent medication to target this disease. I have been tasked basically to talk about preserving against the decrease in energy expenditure. That's true that when we decrease body weight, there is a obligatory decrease in energy expenditure, but there is also what we call a metabolic adaptation. We become more efficient. And it's true that this is one of the problem with weight loss maintenance, because you are fighting against this more efficient energy metabolism. And the second thing is really, we should not talk only about fat mass, body weight, but we should know the quality of the weight loss. Is that fat-free mass? Is that skeletal muscle? I mean, you don't want to lose your brain. And I think that with the kind of weight loss that we are achieving right now, there is a concern about the quality of the weight loss. We know that there is redundancy in humankind in terms of protecting us against weight loss. And I think that we need to target many mechanisms. And I think that this is what we are engaging on now. Even with all these peptides, we don't know exactly what they are doing, but they are doing many things which are favorable for weight loss. And I think we need also to have a better assessment of what these peptides do in terms of energy intake and what are the mechanisms for that. I studied my PhD in the late 70s and was tasked basically to measure energy expenditure in people. And one of them, my primary mentor, was J.P. Flatt, who was a professor at University of Massachusetts, Worcester, who told me energy balance is not just energy in and energy out, but it's really carbohydrate in versus carbohydrate out, protein in versus protein out, and fat in versus fat out. And I became much more interested in not just measuring energy expenditure, but measuring what are the substrate oxidized to generate this energy expenditure. On the next slide, I want just to show you the methods that we've been using. You have basically your total daily energy expenditure is composed of the sleeping energy expenditure, then the cost of arousal, being sleeping versus awake, and become your basal metabolic rate. You have this energy cost of being awake. Then the thermic effect of food, which has also been called the dietary intake thermogenesis. And on the top of that, you have energy expenditure for physical activity, either voluntary physical activity, you go running or jogging or bicycle, or what is called fidgeting or spontaneous physical activity, which is to move a little bit more. Now we can measure very precisely all these different components. The total can be measured by doubly labeled water, like you see on the right-hand side of the slide, and all the other components can be measured either in room calorimeters or with the Hood system to measure your basal metabolic rate. Energy expenditure is important when it comes to body weight regulation. And we did these studies in Pima Indians. I was invited by NIH to build the first metabolic chamber in North America, in Phoenix, Arizona. And we did a lot of measurements of energy metabolism, 24-hour energy expenditure. And like for BMI versus body fat, at any body size, there is a large variability in energy expenditure. And we looked at this variability. Is that involved in further, in prospective weight gain? And the answer was yes. And on the left panel, you can see that you have people with a low energy expenditure in green versus people in blue who have a high energy expenditure. And it was done in hundreds of Pima Indians. And we followed them for 4 years. These were early publication in the New England in the late 80s. And we found that those who had low metabolic rate were much more likely to gain weight. It means energy expenditure is also a marker of the propensity to weight gain or to resist to weight gain. We also looked at the substrate utilization, and on the right panel here, you have in open triangle, you have basically people with a high fat oxidation versus in the closed circle, people with a low fat oxidation. And once again, independent of energy expenditure, we found that the high fat oxidizers were less likely to gain weight. Taken together, it means energy metabolism is important. But how much of the weight gain was explained by energy metabolism? It was less than 25%. And I think that still the major target is food intake, but we have to take into account this. I'm presenting here our approach to look at that. And what we did is to take people and we either overfeed them for a day or two or starve them for a day or two. And we discovered that there were some people in response to overfeeding with a spendthrift. It means they increased their metabolic rate quite considerably, resisting the weight gain. And there were some people thrifty with less of an increase. And during fasting, complete fast, we found exactly the same thing. Some people in response to 24-hour fasting have a drop of maybe 15% of their energy expenditure, and some people only 5%. And we then took some of these people here. This is a case of 12 people. They were inpatient on our metabolic ward in Phoenix, and we put them on a calorie-restricted diet. And we found that this phenotype, being spendthrift or thrifty, was associated with weight loss. It means, once again, energy expenditure or fat oxidation also are major contributors to the level of weight loss and also the quality of weight loss. I want just to share with you some data from The Biggest Loser. I was invited to do measurements of energy metabolism in The Biggest Loser. It was season, I think it was 11. We had 11 people here on whom we had measurement at baseline, week 6 of the competition, and week 30. You may recall that The Biggest Loser was basically taking people with obesity, putting them on a exercise regimen, very, very stringent, but also they were chasing $250,000 for the winner, and they cut down the calories. And you can see that the weight loss was quite spectacular, from 145 kilos at baseline to 87 kilo after a year of the competition. And on the next slide now, I want to show you basically their measurements of energy expenditure, and this is only metabolic rate. We measured the basal metabolic rate with the Hood system, and we measured their body composition by DEXA, which is now like the gold standard to measure body composition. Now you can see on the left-hand side of the slides, those are the women, and on the right-hand side, the men. Now, what do you expect? You can see that some people in response to weight loss are going to decrease their energy expenditure in a shallow way, where some other people have a much steeper slope. And this is what is metabolic adaptation, is really to decrease your energy expenditure more than what you would expect on the basis of the loss of fat-free mass and fat mass. I can show you now the story was taken by the New York Times and all that. We remeasured these people 5 years later. During the competition, at baseline, 6 weeks and 1 year, and then 5 years later. First of all, a lot of these people, and those are data with their names because they were published in the New York Times, you can see that the winner, who is in brown, regained quite some weight. The second one, who was in yellow here, regained quite some weight and decided to go on bariatric surgery. And this is what you see with this yellow line going up and then down. But what was impressive, this metabolic adaptation or this efficiency of energy metabolism was still present 5 years later. It means you fight a low metabolic rate after losing weight. Now, let me take more of this data. You can see the biggest loser on the upper left corner. And these are the data from these people. And then we had also similar data from gastric bypass surgery. But now, it takes longer to lose the same amount of weight with gastric bypass. And we combine these two groups, and the major predictor of this weight, this energy reduction with weight loss was your leptin level. You can see that on the x-axis on the top, a lot of these biggest loser leptin was undetectable. And now in the gastric bypass, which are the squares, you can see that there was still some leptin, but the drop was from 20% from baseline to about 80 or 90%. But the metabolic adaptation or this energy efficiency was related to this leptin concentration. We know that leptin is important, not only on the reproductive axis, but it's a modulator of your sympathetic nervous activity versus parasympathetic nervous activity. That's a modulator of thyroid hormones. And these two characteristics, the sympathetic nervous axis as well as the thyroid hormones, are very important when it comes to your energy expenditure. And I think that's one of the mechanisms by which the energy expenditure become much lower than what you would predict on the basis of the weight loss. And here, I think that we had with NIH a basically meeting to discuss what are the mechanism affecting the metabolic efficiency. You know that there are free fatty acid oxidation in skeletal muscle. Basically, you burn free fatty acid, then you remake the free fatty acid, and it costs energy. You have futile cycles consuming ATP, hydrolysis of triglyceride, and subsequent reesterification. You have energy consumption consuming process. If you make lipogenesis, it costs you energy. Gluconeogenesis costs you energy. You have a lot of modulators of your energy expenditure, and with weight loss, basically you become, in general, much more energy efficient. Now, let me summarize this part. What I told you with weight loss, either you can be like 2B, the green circle here, you can kind of follow the line of prediction on the basis of the population, or you can have a sharp drop in energy expenditure. And what we notice is that it is a determinant of the magnitude of the weight loss. Now, you always hear there are failures with weight loss strategies, lifestyle and so on, but now even with potent medication like GLP-1, there are some people, despite the fact that they take their medication, who are struggling with weight loss. And they may have these mechanisms of basically energy efficiency and so on. I want just now to summarize, when I entered this field, and that's why I'm telling you this is the golden era of basically obesity research, because we had lifestyle intervention. It works. You lose 5%, maybe 7%. If you have Tom Wallen or Gary Foster as your coach, you are a little bit better than others, but it's still a maximum of 10%. Then we had the pharmacotherapy that Claudia presented, and then we had the bariatric surgery. And I think when I was advising for companies or even working for pharma, the goal was becoming to equal bariatric surgery. And fortunately, we are there. It's amazing that now we are achieving not 15, but 20%, even 25% weight loss with pharmacotherapy. The problem becomes the magnitude of the weight loss is really drastic, and we may be losing an excess fat-free mass. Now, you all hear skeletal muscle. It's very, very seldom measured. What is measured is fat-free mass by DEXA, but fat-free mass is water. Fat-free mass is protein from tissue like liver and so on. It's protein from also skeletal muscle. And now we have really to identify this as a problem and targeting this weight loss being fat-free mass and especially skeletal muscle. On the next slide, this is in a publication. We kind of describe, and you will have access to these slides, I believe. We describe the different strategy, and now you know that there are strategies to decrease the loss of fat-free mass or the loss of skeletal muscle by targeting, for example, the activin type 2 receptor, which binds myostatin. And you know that myostatin is an inhibitor of muscle mass development. And for example, you have the Belgian blue cattle with a very massive cattle with a lot of muscle. And this is part of the strategies that now pharma are trying to combine with protectors of weight loss as skeletal muscle. Now, let's just summarize. Bimagrumab block, like I said, the actin receptor type 2, and you have these different compounds which are studying extensively because there is a need now to protect against the potential weight loss as skeletal muscle, especially if you target people at an older age with obesity. Already you have sarcopenia happening with age, over the age of 65 and so on. Now, if you want to target the obesity and you give them some drugs like that, you may really precipitate this sarcopenia, and I think we have to pay attention to that. I'm going to just summarize that there is an important distinction between weight loss and weight loss maintenance. And I think we have to be cognizant of that. This is two different physiology. Weight loss is what pharma is targeting. It's what we are doing pharmacologically. But after that, there is weight loss maintenance. And it may not be the same strategy. We know that you have to continue to take agent to help you. It's like hypertension. If you stop your drug, you get your hypertension back. But the strategy may be different. And I think that this is a very, very important future research to try to change from a GLP-1 or combination to something else, or to titrate down when you have reached the plateau after 9 or 12 months, to titrate down these compounds, introduce something else to basically curb the metabolic adaptation. I want just to introduce this concept. And when I joined Lilly in the late 90s, I presented this slide at my first town hall meeting to say appetite suppressant is really the holy grail for weight loss. But after that, when you reach this plateau, why not introducing compounds, increasing energy expenditure, increasing fat oxidation? And I think this is where we are at. And at that time, it was a beta-3 agonist that Lilly was developing for boosting up energy expenditure. Then we had the brown adipose tissue as a target for that. And I think that this is important to keep that in mind. Now, just to conclude 3 or 4 slides, we know that there's not only the metabolic adaptation, which is counteracting further weight loss or which is favoring weight regain, but there is also your appetite. And this study published more than 10 years ago from Australia is showing that after a period of 10 weeks of weight loss, intensive weight loss, the appetite of these people, and it's on the right-hand panel, after in red and blue, in blue after 10 weeks or 62 weeks in red, they were still hungry. I mean, these people are still hungry. It means they want to eat more. And on the next slide, I'm showing here the orexigenic hormone like ghrelin, which is still up a year after the weight loss, or the anorectic peptides like amylin, like PYY, like CCK, which are still down. And I think we need to really better understand these mechanisms of counter-regulation. We should really be much more rigorous in trying to study by functional MRI all what are the characteristics of this desire to eat, this lack of satiation, these satiety problems. And I think that functional MRI, either with presentation of food or the ingestion of food or the smell of food, what are the characteristics of these response are very, very important. And we have some preliminary data, which are summarized on the next slide, showing that in lean people, basically the viewing of food is eliciting an activation when they are fasted, and it elicits less activation when fed compared to people with obesity. And here, this is a summary again from these studies, but I think we need many more studies like that. We are doing fantastic progress when it comes to basic science using, rats or mice and going into the CNS. But we are very, very poor in our knowledge in adult, and I think that this is an important area of research. But I think overweight adults may show less activation in inhibitory control in response to strategies of either caloric restriction or overfeeding. In other words, more prone to weight gain in presence of overfeeding and less weight loss in conditions of caloric restriction.